Hong Kong, one of the wealthiest cities in the world. This center of global commerce found itself under siege from the air. The city had long outgrown its tiny airport. The onslaught of huge commercial jetliners was endangering the lives of residents. Inefficiency threatened to choke off the lifeblood of the city: trade. Hong Kong desperately needed a new world-class airport. But there was no land to spare. Solving this problem called for one of the most complicated civic engineering projects in history. Others estimated the project would take decades. They were given only 7 years. Could engineers and builders execute a project this extreme? John F. Kennedy Airport in New York. Cathay Pacific Flight 8 for takeoff. It's bound for Hong Kong, but it's about to fly into a great unknown. The pilots have made this trip hundreds of times before, but never like this. Because even as the plane lifts off from New York, in Hong Kong, the airport suddenly goes dark. It's not a power failure. This is an historic event. The culmination of nearly a decade of frenzied planning and construction. Hong Kong has just shut down one of the world's major international airports. And, with planes en route, is moving the entire operation, staff and equipment to a new location in only 7 hours. It's the final hurdle in a 7-year race to complete one of the largest, most ambitious civil engineering projects of the 20th century. It all began in the 1980s, when Hong Kong faced a critical turning point. In the 20th century, Hong Kong had become one of the world's great economies. But these towering skyscrapers masked a glaring weakness. Kai Tak Airport. Dangerous and outdated, the airport sat crammed in the heart of the city. Kai Tak made every flight into Hong Kong a heart-stopping flirtation with disaster, forcing massive jumbo jets to steer past mountains and skim the tops of apartment buildings. More than 6 accidents or near misses occurred at Kai Tak in the last 2 decades. In this accident in 1993, the plane overshot the runway, injuring 22 and killing 2. And there was another enormous problem: cargo. The airport had only 1 runway. It had become a major bottleneck to global trade.
Hong Kong could not continue with its existing airport in terms of passengers, and even more important in terms of cargo. Hong Kong is the biggest international airport in terms of cargo in the world.
With billions of dollars at stake, pressure was mounting for Hong Kong to build its way out of the gridlock. But where? The city was jam-packed, without a shred of available land. There was only one possibility: build the airport at sea. The proposal was mind-boggling. It called for the creation of a new island in the South China Sea. On that island, a massive new air facility, capable of handling the world's biggest jets, and the single largest passenger terminal on Earth. But this massive airport was itself only a small fraction of the overall project. To get passengers and freight to and from the airport quickly, the plan also called for 35 kilometers of new superhighways and tunnels, and a new high-speed rail system. As well as the world's longest double-decker suspension bridge. City planners knew that without a new airport, Hong Kong's safety and economy were at serious risk. The city of Hong Kong had proposed the world's most ambitious engineering project. A system of bridges, tunnels and railways, and the largest passenger terminal ever built. Estimates projected that under normal conditions the project could take between 10 and 20 years. But these were not normal conditions. The project would have to be completed in just 7. A demanding schedule wasn't the only issue. Politics, left over from the 19th century, added a unique twist to this 21st century endeavour. Hong Kong had been a British colony since the Opium Wars. But as part of the peace treaty signed in 1898, Britain agreed to return the territory to China after 99 years. Now, that due date was a mere 7 years away. No one knew how the change in government would affect Hong Kong's economy, or the new airport. There was only one way to make certain politics wouldn't stall construction. Finish the airport before the handover.
The airport was the pawn in this huge game of chess, the political chess that was going on. But Hong Kong's a very unique place in as much that there's very much a can-do, will-do approach to life, and the Chinese work ethic is admirable, and I think it would have been difficult to achieve the progress that we did make in many other places in the world.
In September 1991, the race was on. The first challenge, create enough level ground for the airport. Engineers had their eyes on a pair of rocky little islands called Chek Lap Kok and Lam Chau, 26 kilometers from Hong Kong Island. But neither of the islands was large enough or flat enough to house the airport. One thing was certain. First, the mountains had to go. Then it was time for the army of workers to begin. Commanding giant earth movers, they carted away 200 million tons of rubble. But all that material would not go to waste. It would soon be recycled as fill to turn the two small islands into a single larger one. But before that could happen, the sea floor needed to be cleared. For this task, a fleet of the world's largest underwater dredgers arrived on the scene. Like giant vacuum cleaners, their underwater hoses scoured the ocean bottom, removing a layer of soft mud 12 meters thick to expose the stable rock below. The cleared seabed provided a solid base for what was to come next. A layer of sand, followed by the pulverized remains of the island's mountains. With every truckload, the 2.4-kilometer gap between the two islands grew steadily smaller.
Everybody was under extraordinary time pressure. It was one of the world's biggest land-moving exercises in the history of the world.
Working day and night, inch by inch. Workers on land and sea slowly turned two islands into one. By the time they finished, the workers had moved more than 500 million tons of earth. Enough to fill the Roman Colosseum 200 times over. As the airport island was taking shape, construction crews began the daunting task of connecting the island to the city. Plans called for new tunnels, bridges, and highways to be built across 35 kilometers of land and water. Almost immediately, engineers ran into a problem: finding a way out of Hong Kong across Victoria Harbour. Two automobile tunnels had already been built in the harbour decades earlier, but they were now overloaded with traffic, sometimes causing 2-hour traffic jams at rush hour. A third tunnel was needed. It had to be wide enough to carry 6 new lanes of traffic. Engineers devised a plan to assemble the tunnel underwater from mammoth concrete and steel sections. The sections were manufactured at a harbourside quarry 15 kilometers from the final tunnel location. Each one weighed 32,000 tons when finished, as heavy as a fully loaded ocean liner. When a section was completed, builders capped both ends with watertight seals and then flooded the quarry. The massive tunnel sections were then floated out into the harbour. Once at the final location, the seals were broken, flooding the section and causing it to sink. Divers carefully guided the sections into place. Powerful hydraulic jacks pulled the sections together and created a watertight seal. Then, builders made the final connections from the inside, and the tunnel was complete. It lay more than 15 meters underwater and stretched for 2 kilometers, connecting the busy island of Hong Kong to the mainland. With one waterway conquered, an even greater challenge loomed. Along the proposed route from Hong Kong to the airport, there was one major water crossing to overcome. the nearly 5-kilometre span from the mainland to North Lantau Island. Initially, planners hoped to build another underwater tunnel here to carry airport traffic. But the channel turned out to be too deep, and heavy shipping traffic at the surface would have made underwater construction far too dangerous. So engineers had to come up with another solution. They proposed not one, but two massive bridges, long enough to span the waterways, and high enough to allow even the most gargantuan ships to pass underneath. The longer span, more than 2.5 kilometers long, would be one of the longest suspension bridges in the world. But it was a risky proposal. The bridge would need to withstand one of the most destructive forces on Earth: typhoons. Packing devastating winds, well over 300 kilometers per hour. As many as 8 typhoons slam into Hong Kong each summer. Any bridge built here would have to first prove its strength in the laboratory. To understand how winds would affect the structure, engineers first created computer models. This model simulates the motion of the suspension bridge in a 65 km/h wind, amplified 1,000 times, allowing engineers to identify potential design flaws. Using the data collected, engineers next built a detailed scale model. They placed it in a high-speed wind tunnel and subjected it to a simulated Category 10 typhoon. The results were disturbing. The bridge would become dangerously unstable in high winds. Designers couldn't make the bridge any shorter, so they made it heavier. Below the main roadbed, they added a lower deck for trains and 2 more lanes of traffic. This design stiffened the bridge. It solved a potential problem and added capacity. But for the builders, the design raised the stakes. Now they had to build the largest double-decker suspension bridge in history, with no extra time to do it. First, the building site was leveled. Then, 2 mighty bridge towers were erected. They went up like skyscrapers, each more than 60 stories tall. The plan was to hang heavy suspension cables from these towers to support the massive road deck. But the giant cables needed to be 1 meter in diameter and each weighed 13,000 tons. Because of their massive weight, the cables could not simply be assembled on the ground and then hoisted into place. Instead, bridge builders used an ingenious but risky technique. They built the massive cables in the air. 2 spinning wheels shuttled several small strands at a time back and forth across the towers, each pass adding girth to the massive cables. It's not a job for just anyone. It requires a head for heights and a stomach of steel. And that means specialists, like these sure-footed, fearless Gurkha engineers. Like Sherpas, they come from the slopes near Mount Everest in Nepal and have a long history of mountaineering. By hand and by hook, the Gurkhas guided the spinning wheels and huge steel ropes from tower to tower. Engineers knew that during cable spinning,